Hi girls, so as I said, I was going to leave you a little bit of work, so just going to get that started here now. Now I was unsure, I know we went through this one the last day up here, we did the flag one, I think we did this one and some of us got onto this one, but I'm going to start with this one, so skip ahead if you've this one already done, because I'm pretty sure none of us have this one done. And I told you to do this one here definitely, and the rest of the ones on the back of the page, but just for demonstration I'm going to go through this one here as well. Alright, so it says here we have to rotate the given house anti-clockwise through 75 degrees about point P. Okay, so there's 5 points on it, A, B, C, D and E. Okay, and we've got our rotation point P here. So what we're going to do is we're going to rotate every point 75 degrees anti-clockwise. So we went through these the last day. What we do is we connect P to a point that we want to go anti-clockwise to. So I connect P to A. Let me zoom in here a little bit more. Okay, connect P to A. Just the lighting. There we go. Bit better. Okay, so step 1, connect P to A. Put your protractor on P. Set the 0 out, and we're going to read it around as far as 75 degrees from the 0. 10, 20, all the way around 70, 70 going towards 80, 75. Okay, so this one here is for A. So what do I do if I want to find A now? Set my compass out as far as A. I can rotate the fully around, or you can just rotate apart. So there's A1. Okay, now we're going to go on to B. So same concept. From P to B, set your protractor on P with the 0 going out as far as B. Reading around to 75 degrees. Exact same concept, only this one is for B. Now I would encourage you to do it one at a time so you do not get confused. Compass on P, pencil part of the compass onto B, rotate around until you find B. Okay, now what I'm going to do is the same for C, D and E. I'm going to go a little bit quicker now. So for C, I'm going to read around to 75 degrees. I'm just going to label that one with a C there. I'm going to do them all in one go now. This one is for D. Try to get the exact point. Okay, all the way around as far as from 0 as far as the 75 degree mark. Okay, that one is for D. And finally for E. You can see why I write the letters so I don't get confused. P. Yeah, I'm happy with that. As far as 75, which is there, and this is E. And there we have. Okay, so compass as far as C. I'm going to rotate C around until it goes to there. I've now found C. Next one is D. There's D. And finally E. And E is there. Okay. So there we have it. A, B, C and D. Now what I'm going to do, connect them up. So A connects to B. B connects to D. See what the accuracy looks like. And there we go, not looking too bad. Now in regards to getting the door is on the line from B to D, so I'll connect those, B1 to D1. Okay, and the easiest way for me to get the door then is take the distance from D to this point on the door, which is the same as E to that point. So then I can mark it from D and from E, and I'll do the exact same then again, only D out to the opposite one. D out to the opposite side of the door, and E. I'm going to mark it out. So there we go. maybe that in, maybe this, and this. And there we have the house has been rotated anti-clockwise about the point P 75 degrees. Okay, so that one was done. You probably had that done, guys. So I'm going to move on here now to the last one on the page. So this one here, there's a slight difference in it, guys. Okay, it says here we have to rotate the given rectangle A, B, C, D until point C comes into contact with the line PQ. So I've got a line PQ here. So our rotation point is P once again. So what we essentially have to do is we're going to rotate the object until point C of the object hits the line PQ. So from P, I'm going to rotate C until it gets into its new position. Now what you could do here, okay, is this. You could take the distance, sorry, not the distance, the measurement. You could join P to C, and what you could do with your protractor is you could measure this angle and work out the angle. Okay, so if I was to actually measure that, I would actually have to extend out this line here a little bit further. And if I was to measure that angle, and for me there it's reading at 71, 2, 3, about 73.5 degrees. 73.5, and I could use that then, 73.5 for B, C and D. However, there is a quicker way, okay? So, C rotates anti-clockwise. Let's take D. D also would rotate anti-clockwise. Okay? Now, somewhere along that arc is going to be point D. It is not where it hits the line PQ. Okay? It's going to be out here somewhere. How would I find that? Well, one easy way to find it is, because I have the position, the new position for C, you could take the distance on the object from C to D like this. You could take that distance there. You could put it on the new position for C and swing an arc. And where that arc cuts through the rotational arc for D, that gives me the exact position of D, which is now D1. Okay? So, I can now join C1 to D1. Now, how would I find A? Same concept. So I'm going to rotate A until it gets into its new position, somewhere along the inside arc there. So now I can take the distance from D to A. Okay, put my compass on D, swing an arc. You can see the little arc there. We have now found A1. And at this point, I could technically do sliding set squares. So I'm just going to rotate B first. Same concept. B is out along this arc. I could take the distance from C to B, like that. My compass on C, out as far as B. And there we have it. There's B1. Okay, so that is the other way that rotations can be completed. And there we go. There is the object rotated around until point C hits the line PQ. And what I did then was, rather than using all the angles, we can actually take the measurements of the objects to find it. Once we had located one point, we can take the distance then of the lines from C to D. Once you had the new position of C, swing an arc with C to D as your distance from C1 to cut the line. Okay, so that's that one done. And I'm going to turn it around here, guys. So once again, fast forward in the video. Get this done as quickly as possible. These guys, that's essentially the topic covered. The questions on the back are just quick practice questions. Okay, they are based on rotations and they are based on axial symmetry. So I'm going to set this up, and they are a little bit tricky now, these guys. These are all old exam style questions. So the first two, quite easy. I have no doubt you don't even need to listen to the video. If you want, absolutely, or I'll skip ahead until you get to this one. So, question number 1 on the page. This is an axial symmetry. So what do we have to do here? We have to get the mirror image of the microphone. So all we're going to do is, the axis is line LL1 is a horizontal line. So complete the logo of the microphone by constructing an axial symmetry in the line LL1. Bring the line down, bring the line down, bring the line down. Now, all I have to do, first of all, I'm going to start with the circle. Put my compass on the center point of the circle, pencil out to the radius point. and all I can do is that. Okay, now that's going to be the point right there, where it's similar to that. Now to get the other points, take the distance from the axis to this point, mark it down, and do the exact same with this one. Axis to the point here, and mark it down. Really easy. That is that question done, outside of just having in the details. Okay, so there is our microphone. Now obviously at the end of any question, you always try and just, know the story, girls, heavy in those details a little bit more. Okay, next question. Okay, this one is based off of a lamp. Once again, axial symmetry, same principle. Baseline is going to come out horizontal, our axis is vertical. Okay, the lamp shade, this bit will come out, and this bit will come out. How do I do it? So the first one, I'm going to focus on the circle, put my compass on the center, pencil up to this point, to there, and we'll rotate it around till it hits the bottom. And there we go. Now we're going to do the same for the lampshade. That goes to there, and there, and here. Okay, and then just finishing it off, need to get the neck of the lamp from there in, make a little mark. You can see my tiny little mark there, and a vertical line down, and that is our lamp. Okay, now what I'm going to do here is this question number 4 next, and then we're going to get on to all the rotations. Now essentially what they're asking us to do here is, this is like a rectangular sheet of paper, okay, and we have an opposite corner to join to the opposite corner, and they want us to take this part of it and flip it over. Okay, so it's like they're taking this triangle AB, and let's say we had point C here, and they want us to flip C over. So C essentially needs to move perpendicular to the AB axis line. So the way to do that, I'm just going to zoom out here so you can see it a bit better. I'm going to get the long edge of my 45-degree set square. Okay, the long edge of my 45-degree set square, put my other set square underneath it. You can see this here. Long edge of 45, put it on the AB line, the line we want to go perpendicular to. Get the other set square and put it underneath it, and then rotate our set square. And now we are perpendicular, but I need it to go through point C. Now this was actually a tricky enough question. Lots of students wouldn't have recognised that. Okay, now all we do to complete the question is we are going to go from C like that, join it out, because that's our axis line AB. And then to complete the question, that's what our sheet of paper would look like when the top half is flipped over. It's like when I take the top half, flip it over. Okay, so there's that one. Now we're going to move on here to the left hand side of the page, and we're going to do this one here based on an adjustable set square. So what we have to do here, this is called an adjustable set square. Basically it's a type of set square you may use in senior cycle DCG girls, but basically it can be rotated, okay, and you can see that it can actually move. The top portion can kind of separate from the bottom, and it has a hinge point, okay. So what they say is the figure below shows the draft or the drawing of an adjustable set square. A 3D graphic is also shown. Here's the 3D graphic. What we have to do is rotate A, B, C, D about point O, there's point O, until point C reaches the line L1. Now imagine the whole object A, B, C, D is going to rotate as C goes up. What is it going to do to the other points? So if C goes up, well, D is obviously going to go up. B is actually going to go backwards, and A is going to go down. So let's start rotating. So this is very similar to the one we did in the back of the page with the rectangle, rotating it. Okay, just we have an irregular shape. So C is going to rotate up until it gets into its new position right here, which I'm going to call C1. Now the next point I want to find is B. So what direction did B go? So I'm going to adjust my compass here until it goes onto B. If we lift it up, B is going to go back. Okay, somewhere along that arc is B. So what can I do? I can now take the distance from C to B. Okay, because that is the true distance. I can put it on the new point for C, which is C1. Let's mark it off. There we go. There's B1. Just draw it in. Okay, I'm going to draw it in with my red. Okay, so that is CB. Now I want to get from B to A. So let's rotate A first. So what happens as this lifts up, A will actually come down. Okay? So A will actually come down there somewhere. How do I find it? I can take the distance from B to A. You could also take the distance from C to A and mark it from C. I'm just going to take the distance from B to A and put it on my new position from B and mark it. And you can see where the two arcs cross. And now we have found A1. Same concept. Let's join them. So the new position is here. Okay, now the last point we have to find is D. So from O, D is also going to go up like that. Now, you'll see here when I do A to D, like that, and I put it on A, you can see the arcs are very close to each other. Okay, so the debate there is whether it is the point here, 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 here. We can't get the exact position. So when something like that happens, I'd encourage you to go to a different point on it and maybe take the distance. Watch here, I'm going to take the distance from B to D. So just go on using the original object. You can also use a diagonal line going across the object. So I've taken the distance from B to D, but it's important that I go to the new position for B. And watch this. When I swing the arc from the new position of B, that one there is kind of crossing over it much more clearly. So then that one there gives me the exact position for D. So then that allows me to draw it here. So A will connect to D. A little bit of inaccuracy there, kind of jumping over the point. It probably should be hitting right there, but close enough. Okay, there you have it. That there is our, I suppose, our new position of the object A, B, C, D. Just going to quick bit of colour here. Might help it stand out a little bit more on the screen. So that's the object A, B, C, D, rotated. Okay, so there we have that one. Now we're going to move on to the one at the bottom. Okay, so one at the bottom here now. Nearly done. So this one says, this is very like the last page. Okay, the figure shows an elevation of a gavel on a block as used by a judge in a court. So you know the way a judge kind of hits down on top, obviously, when they're making their judgments. Also shown is a 3D graphic of the gavel and block. So there's a 3D guy. Okay, and we've got the 2D views here. So this is obviously the handle, that's obviously the block or the gavel bit, and this is the block. It tells us rotate the gavel A, B, C, D about point O. So point O is down here. So A, B, C, D rotate about point O until it reaches the top surface of L, L1. So what we have to determine is, out of the 4 points A, B, C, D, which one of them will hit the line L to L1, the top line here. So obviously D is the closest, so it makes sense that D will actually hit it first. I'm going to rotate D down. Okay, and that is my new position for D. Now don't assume that A will also hit it. Okay, it's not going to go flat because it's just going falling down. Okay, O will stay in its fixed position. So A is going to come down next. So somewhere along that arc there is A. How do I get it? Well, I could take the distance from D to A. Okay, take that distance there. Go to D here, the new position, and mark it off. Okay, and once again, I think they're quite close, but nothing wrong with what I've done, but I do think they're quite close. So I'm just going to check it. I'm going to label it for now. Okay, but I'm also going to try and find C. So put my compass on O, pencil out to C, and what you'll actually see is C and D are pretty much on the same arc. They're close enough. Okay, so how am I going to get C? Well, I can take the distance from D to C, put it on the new position for D, and mark it off. I've now got an exact position for C, which I'm going to call C1. Okay, now what I could do, just to determine A to be 100% accurate, I could take the distance from C to A. Okay, put it on C1, and you can see there I was about a tiny touch off. It's right there, more so. Now I'll start drawing it in. So now that I have D to there, more happy with that now. And here. Okay, so I've got two edges. Now the last one I'm going to find is B. So how do I find B? Well, I have to rotate it. It's going to be very close to the A1, I'd imagine. Very close, just sitting on top of it as well. Okay, I'm going to take the distance. I'm going to do from A to B. So there's A to B. Put on my new position for A and mark it off. And that there is B. So let's heavy those in. Now don't forget, it's just not heavy in there, sorry. There we go. Now don't forget, you have to put the handle in as well. Okay, so this point right here, that point there is right in the middle of D and C. You could bisect the line, but it's just as easy. Take the distance from D into the middle, and then go to the new position for D and mark that point off. And there we go. Right, there's the question complete. Last question. Okay, this one is probably the trickiest one. So it says here, the figure shows the end view of a swing seat. So what they're saying is it's like we're looking in from the side here, the end elevation. Okay, so it's like we're looking in from the side where we see the triangular kind of shape here, obviously, which is what the swing is kind of, I suppose, swinging off. There's the ropes for the swing, and there's the seat. Now, it tells us, also shown as a 3D graph of the seat, we have to rotate the seat about point L, so there's point L, until point P, this point on the seat, reaches the line L to L1. So L to L1 is down here. So just reading the information. Now what I'm going to do is I'm going to call more points on the object. So I'm going to label this point as well. We'll call that Q. I'm going to label this point R. I'm going to label this point S. And this point T. I'm not going to worry about these 2 points, and you'll see why. Okay, so it tells us rotate the seat about point L until point P hits this line. So that's what we have to do. L is our rotation point, compass on P. So rotate P until it hits its new position. And there I have it. I'm going to call that P1. Now, the next point I'm going to rotate is R. I won't do Q yet because the Q is on the line connecting from P to R. So P to R is a line and Q is on that line. So I'm going to find R first. So let's rotate R. Same concept. R is going to rotate out there. Somewhere out along there is R. How do I find it? I can now take the distance from P to R. So I have the new position for P. Put it on P1. Swing an arc. And now we have R1. Let's join them. Okay, somewhere along that line is Q. Let's find Q now. So all I have to do now to find Q, rotate it. And that there is the new position for Q. Okay, now we need to find S and then T. So let's rotate S. S is out there somewhere. How do I find it? I can put my compass on R, pencil on S, take that distance there, put it on the new position for R, swing an arc. That there is S. And the exact same concept now with T. So let's rotate T. T is out along that arc. Let's take the distance from Q to T. So, and there we go. And there is T1. So let's join them in. That's looking pretty good. And now, to get these points in here for the swing, I'm going to take the distance from Q to the point here and mark it from Q1. I'm also going to take the distance from R to this point and mark it from R1. And then simply join them. So there's no need to rotate them. Okay, there we've got that. Now what are we missing? Don't forget the swing arms. So the one connects to Q and the other one connects to here. So from L, there we go. And there we go. So there's the swing as it has rotated about. Okay, so there you have it, guys. That's your work there for the class. Okay, I hope you enjoy your midterm, girls. Have a good break. All right, well done.